Alright, so warm-up number 31. Once again, for number 1 it says solve 2/5 r plus 3/10 equals 1/20. For number 2 it says factor 2x squared plus 9x plus 9. And for number 3 it was solve for y and graph using the domain -2, -1, 0, 1, and 2. And equation given was -6x minus 3y equals -3. So for right now, the only thing I want you to share with your neighbor is what you got for number 1. What you get for number 1, please. Alright, let's see. Sebastian G, what'd you get? R equals to what? -5 over 8. Hands if you got that. That is correct. And once again, how to... Oh, it's frozen. Let it go. Let it go. Have you guys heard that song? There's this... Times the common denominator, which was what? 20. Distribute. We only distribute to the what? Numerator. So this is 40 over 5r plus 60 over 10 equals 20 over 20. Simplify that. That becomes 8r plus 6 equals 1. And the rest is history. Solve using numbers operations. That's how we get there. Okay? Number 2. What'd you get for number 2? Diego. You can do that one? Okay. Help him out, Kevin. X plus 6. 2x plus 3. Close. Maritza? X plus 6? Hold on, am I making a mistake? Let me double check. 18, 9, factors of 18 that add to 9, 6 and 3, therefore 2x squared plus 6x plus 3x and then 9, group. GCF here is 2x, we're left with x plus 3. GCF here is 3, we're left with x plus 3. So the factor should be x plus 3 and 2x plus 3. Hands if you got that? Yeah. Just be careful with these, because I know your noodle might want to use the shortcut for these, going straight from here to here, but we can't do that with these, yes? Now, there is a shortcut, by the way. You guys ready for the shortcut now? With these that have a leading coefficient? Y'all ready? Sure. Here it goes. What's my leading coefficient? 2. Once we do this, check this out. Ready? So where did I get the 2 from? From the leading coefficient, right? Okay? Question. Can I simplify this anymore? Yes. Yes. You guys see it? Yeah? Do you guys see it? No? The 2, the 3. What is 6 divided by 2? 3 over 1, yes? The 1, the 3. You're like, what? I know. Anyway, students, Jaime Escalante method, students. Those of you that were with me in Algebra 1, I kind of mentioned this one, but I said not to use it because we needed extra practice with grouping. Jaime Escalante was a math teacher in the LA Unified School District. He came up with this method. He comes out in a movie called Stand and Deliver. Who's seen that movie? Yeah. I'm going to see if I can get some permission slips so that we can watch it here maybe one day, yeah? Those of you that haven't seen it, it's pretty cool. He's, anyways, he passed away already, but he left the LA school district. He moved up north and finished his career up there. All right, number 3. What'd you get for number 3 equation? Mario. Negative 2x plus 1. Hands if you got that. That is incorrect. Y equals negative 2x plus 1. Alright. So, we need to graph this. So I'm going to use this domain to save time. I'm just going to go like this. 6 up. X. You're like, what? I know, right? I'm telling you, I got a lot of tricks. Let's go. Range. What'd you get for the range? Sebastian G. Pass someone. Leo. Are you asking me or? Oh, you said negative 3? Close. What is the value of x? Negative 2 goes here, yes? So negative 2 times negative 2 is positive 4 plus 1, 5. Be careful, guys, when you're substituting. Next value, negative 1 goes in here. Negative 1 times negative 2 is 2 plus 1 is 3. Now, your brain should start picking up a pattern. So the next value is 0. 0 times negative 2 is 0, plus 1 is 1. So now that you see the pattern, tell your neighbor the next 2 values with that pattern. Yeah, negative 1 and negative 3. Hands if you got that. Okay, let's graph this. Now, if you notice now, our domain and the range are balanced. We have negative values and positive values for both. So that means our coordinate plane should be pretty balanced, like this one. This is my x, this is my y. So for my x, I have negative 2, negative 1, 0, 1, 2. For my y, I have all the way from 5 all the way to negative 3. So I go 1, 2, 3, 4, 5, 1, 2, 3, and we graph. First point, negative 2, 5, negative 2, 5, negative 1, 3, 0, 1, 1, negative 1, and 2, negative 3. And connect the dots or the points from left to right, and there you go. And if you got something like that, okay, good. Copy the agenda for today. And like I said, today's going to be a fun session. Let's go. Warm-up number 31, rational functions. We're moving on. And tonight's home play was pages 459, 460, numbers 3 through 6. So how many problems do you have today? Four problems, guys. Is everybody all right? Yeah? You're like, I wonder why only we're doing 4 problems. Because I'm nice? Thank you, Martian. Yes. I am very nice. No, because they're long problems. And yes, I mean, I'm nice, but I could have given you more problems, right? All right. So, for those of you watching online and those of you that are going to Nearpod to get the play sheets, Nearpod code is VNPD7. VNPD7. In there, you're going to find the PDF of the pages, so make sure you go there. But it's also on Canvas, so you can go to Canvas and get that. So last night's home plate, get that out. Take pictures, submit on Canvas, write your name, date, period on it, send them forward, please, and then from there send them to your right over there to Justin, so you can put them over there by the drones. Give you some time for that. From there, get a Cornell note ready, and reminder, tonight's home plate, 459, 460, numbers 3 through 6. Get a Cornell note. You do need a fair model, okay? Let me pause this real quick. Here we go. Our objective for today, I can solve rational equations. So we're moving into the functions realm, but before I throw you completely into the pool without knowing how to swim, we're not doing graphing yet in functions. We're just going to be solving equations today. It is going to get funner by the minute, but we'll take it one problem at a time. So what is our main concept for today now? Rational equations. That goes in your FAIR model. Yes? Okay, so you wrote that rational equation in your FAIR model. Good. And here goes the definition. What are rational equations? Rational equations are equations that contain one or more rational expressions. Which by now you should know the definition of a rational expression, yes? Can you picture a rational expression? Yes. So according to the definition, rational equations are equations that contain one or more rational expressions. Examples: 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equals 1. 2x plus 6 over x squared plus 5x plus 6 equals 1 over x plus 3. Those are examples of rational equations, and once again, according to the definition, as you're writing these down, it says, you wrote them down? Okay. It says, equations. Do we have equations? Yes. That contain one or more rational expressions. Let's see, rational expression, yes, yes, and yes. Okay. Now that we know what they look like, let me show you what they are not. Don't copy that yet. Look up. There's 3 different nots. So tell your neighbor why these are not rational equations. Tell your neighbor why these 3 are not rational equations. All right. Good combos, yes. All right. Why is this one not a rational equation? Marshall. It's not a one, I'm sorry? It's not over anything, so it doesn't have any fractions, so yeah, that is true. So this is just a regular linear equation. Okay, pass someone, Marshall. Who? Who? Sky. Oh, Sky, my bad. Sky, why are these 2 not rational equations? I'm sorry? I couldn't hear. No equal sign. Yes, these are expressions, but no equal sign, so they are not equations. Okay. So, what would be the most important thing to remember about rational equations? Hashtag what? Fractions. Okay, I heard. Fractions. What else? Hashtag equal sign. Bam. So, hashtag equal sign, hashtag fractions. What else? What else do you see all over the place? Very good. Polynomials. Is that pretty good, yeah? How about a hashtag BAM? Alright, let's move on. So, for today, we only have 4 basic steps. Here we go. Step 1, copy these, please. Now, we've been doing this on the warm-up. That's why I gave you plenty of practice with simple ones. Step 1, it says, when the rational equation is a proportion, cross-multiply and solve. Have we done some of those on the warm-up? Have we done some of those from the beginning of the school year? Yes, Mr. Q. Or, yes, Mr. Q, thank you. You're welcome. However, if they are not a proportion, what do? Well, we first identify the least common denominator, or a common denominator. What do we do then? You multiply the entire equation by the LCD. And lastly, you simplify and solve. Make sure you use those codes. Those are the codes I'm going to be using throughout the session. Copy that and go. Alright, so I'm going to leave the steps on the top right of the screen, but copy example 1. Example 1 says, solve algebraically, and then identify excluded values. Equation given is 5 over x minus 2 equals 3 over x. Alright, we're going to do this one together since we've already done these. Okay, but I'm going to just write out the problem just to make sure that everybody's following along. Here we go. So I'm going to start with step 1. Step 1 says, when you have the rational equation being a proportion. What is a proportion? A fraction equal to another fraction. Do we have a fraction equal to another fraction? Yes. We cross multiply. So check this out. I'm going to start with the smallest one. So this times that. I'm going to write it out so you guys can see it. 5 times x. Okay. Then equals to this times that. 3 times x minus 2. Did I cross multiply? Yes. Copy that. Alright. Next. Now that I cross multiply, step 1 is done. I go to my last step, which is simplify and solve. Look at the right side. Can I simplify the right side? Yeah. Distribute. This is 3x minus 6, and this is 5x. Can I continue solving? Yes. Line down the equal sign. I need to get all variables to one side. Where do I start? I like to start with the smallest variable, which is what? 3x. So how do we get rid of 3x? We subtract 3x, and what do we do to one side? We do to the other. This cancels. We're left with 2x equals negative 6. Last but not least, we divide by 2. Divide by 2. Giant 1 right there. We're left with x equals negative 3. Fairly simple, yes? Are we done? No. Excluded values. So you're like, okay, there's a dilemma here, Mr. Q. Do I go with whatever the denominator is here, or do I go with the original denominators? What do you guys think? The original, yes. X minus 2 equal to 0. X equal to 0. This is already solved. Plus 2 plus 2. X equals 2. Very simple. And you're like, Mr. Q, haven't we been doing these? Yes, that's why I gave you these on the warm-ups. From 1 to 5, how comfortable do you feel with these? Yeah, 5 fours, okay. I'm going to give you one just like it. You do the whole thing. Ready? Here we go. Example 1Q. We got 1 over x equals 3 over x plus 4. I'll give you a minute, copy that, and go. Alright, let's see. Here goes the process one more time to make sure you got it. It's a proportion, yes, Mr. Q, fraction equal to another fraction. So I'm going to start with the small ones. This is 3 times x, and this is 1 times x plus 4. I'm just writing it so you guys can see the process. From there I go to simplify. Distribute. We're left with x plus 4 equals 3x. From there we get all variables to one side. I start with the smallest one, subtract x. That leaves me with 2x equals 4. Last but not least, divide by 2, x equals 2. Hands, have you got that? Okay. Excluded values, of course, you use the original denominators. You wrote x equals 0, x plus 4 equals 0, and you solve, so x equals negative 4. Hands, have you got that? Okay, from 1 to 5, how comfortable? Yeah? 5, 4, okay? Shall we crank it up a little bit? Yeah? All right. Example 1 super cube, copy this. X plus 1 over x minus 2 equals to 4 over x minus 3. So once again, let's see. Let's do this one together again. Step 1, is it a proportion? Yes, Mr. Q, fraction equal to another fraction. We cross multiply, start with the smallest one. What is the smallest one? The 4. Cross multiply this way. Now look, I'm going to write it out first. So that means 4 times x minus 2. So that we can see it. Equals to this times that. Let me write it out. X plus 1 times x minus 3. Why do I write it out? So you can see it. So we're done with step 1. Let's go to simplify. Here we go. Can I simplify the left side? Yeah, distribute. We got 4x minus 8 equal. Can we simplify the right side? Yes, I'm going to use different colors so you guys can see the process one more time from when we started. We started with these 3 weeks ago. What is x times x? X squared. X times negative 3. Negative 3x. Remember these, yeah? Oh yeah, they're coming back. 1 times x. Positive 1x. And 1 times negative 3. Negative 3. Can I simplify more? Yes, I can combine these, so I'm left with x squared minus 2x minus 3, and all that equal to 4x minus 8. Bless you. Is everybody following so far? Yes? Yeah. Okay. But we're still not done. We still need to what? Solve. However, now it's a quadratic equation. Let's think back to when we did quadratic equations. I showed you 3 different ways. Factoring, square roots, and graphing. But for all of them, we needed to make one side equal to what? 0. That means I need to make one of the sides 0. Which one would be the easiest to make 0? This side over here. So what am I going to do? Minus 4x plus 8 minus 4x plus 8 to both sides. Negative 6x plus 5. Does this look familiar now? Yeah. We need to solve this. How do we solve it? We need to factor it. How do we factor it? Tell your neighbor. But 5. Our product is 5 and our sum is negative 6. What 2 numbers multiplied give me positive 5? Then when you add them, give us negative 6. Tell your neighbor those 2 numbers. Yeah, negative 5 and negative 1. So if we use a shortcut, we can write our factors as x minus 5, x minus 1. all that equal to 0. Is it coming back? Yes? So now that we have these two equal to 0, this is equal to 0, so we set it equal to 0, so I'm going to write x minus 5 equal to 0, and x minus 1 equal to 0. Let's solve. Plus 5 plus 5, x equals 5, plus 1 plus 1, x equals 1. These are my solutions. X-intercepts, roots, zeros. Yes? All right. Pretty straightforward. From 1 to 5, how comfortable do you feel with these so far? Yeah, 5, 4, 5. We need more practice, yeah? Are we done? No, excluded values. What shall I write? Umberto. X minus 2 equal to 0. X minus 3 equal to 0. Yeah, from the original denominator. So x equals 2 and x equals 3. What's that? No, just the original denominators. Okay. All right. Ready for one just like it? All right, copy this one. Example 1 mega cube, 8 over x plus 3 equals to x plus 1 over x plus 6. Copy that, and I'll give you, what, 1 minute? A little bit more? Okay, 1 minute and 1 second. Copy it. Done? Alright. Here goes the process one more time. Is it a proportion? Yes, Mr. Q. I'm going to start with the smallest one, which is 8. Distribute this way, so I'm going to write 8 times x plus 6 equals this times that, x plus 1 times x plus 3. Does the order matter? Not really. You could have had them flip-flop, whatever the case. From there I go to, that was step 1, go to the last step, which is simplify and solve. This becomes 8x plus 48 equals, this becomes x squared plus 4x plus 3. Check your work. So far so good? From there, I'm sorry? 3x? Alright, let me work it out. Careful with your distribution. Yes? This is 4x. Yes? Okay. From there, minus 8x minus 48 minus 8x minus 48. We end up with 0 equals x squared minus 4x minus 45. So far so good? Negative 45 and negative 4. What two numbers multiply give me negative 45 and you got them give us negative 4, negative 9, and 5. Factors, x minus 9, x plus 5, and all that equal to 0. Therefore, x minus 9 equal to 0, x plus 5 equal to 0. Therefore, when we solve, x equals 9, and x equals negative 5. Hands, have you got that? Okay, good. So far so good, yeah? From 1 to 5, how comfortable do you feel with these, yeah? How about excluded values? Tell your neighbor what you're going to write to get started with excluded values, please. Yeah, so we go with the original denominators, this one and that one, so that means I'm going to write x plus 3 equal to 0, x plus 6 equal to 0, solve, so therefore x equals negative 3, and x equals negative 6. You good? Like that guy from the video goes, like, anyway, now, shall we crank it up to like 4 notches? Is that alright? Yeah, let's do that. Example 2, copy this. The master plan is working. 6 over x plus 2 minus 10 over x equals 4 over 2x. You're like, oh snap. Oh snap is right. Do we have a proportion? No. So that means we cannot use step 1. We can't cross multiply. I skipped that step. Therefore, what do we do, Mr. Q? Well, let's go to step 2. It says, identify the common denominator. Why? Because we need to multiply the entire equation times the common denominator. Now check this out. I'm going to do this work on the side, so writing utensils down, look up. I'm going to write my denominators over here. I got x plus 2, I got x, and I got 2x. I'm going to start with the smallest denominators, which is these 2. And I'm going to ask the question, can I make this one like this by multiplication? No. How about this one like this one? Yeah, so what would be my common denominator for these 2? 2 times x, is that correct? Because all I have to do is multiply this times 2. Does that make sense? Alright. However, now I have, these are already common, I have this one. Can I add something to make it look like that? No. When you get to these points, we need to multiply these 2 to make it a common denominator. Before you copy that, let me show you with numbers so you can see the mechanics. I'm going to use 3 numbers for denominators. I'm going to use, for this one, I'm going to use the number 5. For this one, I'm going to use the number 2. And for this one, I'm going to use the number 4. What would be a common denominator for these 2? 4, is that correct? Because all I have to do is multiply this one by 2, is that correct? Which is pretty much what we did here. However, can I add here to make it a 5? No, for denominators we need to multiply. That's why we end up multiplying these 2, 5 times 4, and that would give me 20. That make sense? Now we're doing it now with polynomials. So copy this, and then we'll move on to the next step. And if you want to have this as a reference on the side, it's up to you. I just wrote it there so you guys can see the mechanics using numbers. Yeah. All right. So step 2 is done. Did we identify our common denominator? Yes, this is our LCD, least common denominator. Okay, why do we need that, Mr. Q? Because for step 3, it says multiply the entire equation times that. So follow along, copy this. We're going to multiply everything times what? 2x times x plus 2. And we're going to multiply the numerators only. Okay? Now here he goes. Writing utensils down, look up to the screen. I was doing it with numbers and the warm-ups and from the beginning of the school year. Now it's with polynomials, but it's the same process. Check this out. What do I have in the numerator here? 6, and I multiply that times what? All of that. 2x, x plus 2, and the denominator stays the same, x plus 2. Next, minus. What do I have here? 10, and multiply times the common denominator, which is 2x, x plus 2, over the denominator, which is the same. Okay, stays the same. Equals. Yes? Last, what do I have here? 4 multiply that times 2x, x plus 2 over 2x. Copy that, and then we'll do the last step together. So that was step 3. All right. So what is step 4? Because we're done with step 3. It says simplify and solve. So now, why do we multiply the entire equation times a common denominator to get all simplification? Yes? How have we done simplification? Yes? Yes, using giant ones. Do you see any giant ones? Yes, Mr. Q. I see this one. Get it? This one. How about here? This one. Yes? Okay. How about here? Yeah, the 2x and the 2x. Yes? All right. So what do I have left over here? What is 6 times 2x? 12x. Minus, what is 10 times 2? That's 20. Times x plus 2 equals, what is 4? Oh, I'll leave it as 4 times x plus 2. Did we get rid of the fractions? Yes. Now can we work with this? Yes. Let's get started. Can we simplify the left side more? Yeah, I'm going to distribute this negative 20 in here, so that gives me negative 20x, negative 40. I'm going to bring down the 12x. Can I still simplify? Yeah, combine these two, is that correct? That leaves me with negative 8x minus 40. I'm done simplifying the left side. Let me go to the right side. What is 4 times x and 4 times 2? That is 4x plus 8. Does that look fairly simple? Yes. Now we just get all variables to one side. I'm going to go back to green. So, which is the smallest variable? Negative 8. So to cancel this one, I add 8x to each side. We're left with negative 40 equals 12x plus 8. And then minus 8 minus 8. That gives me negative 48 equals 12x. And last but not least, divide by 12, divide by 12. That leaves us with, I'm going to write it over here, negative 4 equals x. Whoo! Let's go. It's just work, if you notice. Is it a quadratic? No, that's why we didn't do any power ranges or anything like that. It's straightforward, a linear equation. Okay, from 1 to 5, how comfortable we'll deal with these? 5 4s, 5 4s. Are we done? No. Excluded values. What would I write? X plus 2 equal to 0. What else? X equal to 0 and 2x equal to 0, and you solve and so on and so forth. Before you go, I know you're packing up and the bell already rang. Look up really quick. Tonight you're going to see something called extraneous solution. What does that mean, Mr. Q? When you solve your equations, then you get your excluded value. If one of the excluded values is a solution, then that an excluded value cannot be a solution. That's known as an extraneous solution. I'm going to include that in the video so you guys can review that. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.